Let's go nuclear. Hold on, don't leave just yet. I promise I'm not completely crazy. Give me a chance to explain. Let me ask you one question about nuclear energy. Can you name one problem about nuclear power plants? One specific problem. One that is specific to it as an industry. One problem that isn't it's dangerous or it produces dangerous waste. Conversely, let me tell you the issues with fossil fuels. They are limited and non-renewable. They result in massive carbon emissions, destroying the environment and cause extensive pollution. While currently most of the world's power comes from burning fossil fuels, fossil fuels include coal, propane, oil, and a whole lot more. This burning releases a lot of pollution that causes climate change, damages environments, and causes a plethora of diseases. Climate change is easily the worst effect of burning fossil fuels. It creates stronger hurricanes, more droughts, more flooding, and rising sea levels. Hashtag stop climate change. These impacts extend beyond an increase in temperature. It affects ecosystems and communities in the United States and around the world. So why nuclear? In comparison to fossil fuels, nuclear energy has no carbon emissions and is therefore a source of clean energy. That means it doesn't contribute to climate change. I mean, could nuclear get any better? Yes, it can. Nuclear energy saves lives. Yes, it's true. Pollution from the burning of fossil fuels causes a variety of cancer and other diseases. Since 1976, about 64 gigatons of greenhouse gas emissions have not been pumped out thanks to nuclear energy. Additionally, countless cases of cancer and lung disease in coal mines have been avoided as a result. I would even go as far as to argue nuclear energy benefits human lives. In fact, a study conducted by NASA found that nuclear energy has saved more than 1.8 million people from death from 1976 to 2009 through producing energy that would have otherwise been produced by fossil fuels. In fact, nuclear energy ranks in last for deaths per unit energy produced. I mean, NASA can't be wrong. I mean, they put people in space for a living. When a nuclear power plant fails, it goes boom. The effects are broadcasted across the world, and the whole industry gets a bad reputation. Unfortunately, coal and oil industries kill silently. They slowly pollute our air, which gets worse and worse. However, not much attention is paid to the deaths caused by other industries. It is so much more interesting to watch a nuclear meltdown than it is to watch a coal plant slowly burn and burn and burn and burn. I digress, but there are two main issues opponents with nuclear facilities present: the facilities themselves and the waste storage area. However, these facilities are legally mandated to follow intensive regulations which protect the facility and reduces the risk of danger. Additionally, the waste is stored in hard to access and remote areas to protect other people. Conversely, coal plants pump out all their byproducts into the atmosphere. The Earth isn't a trash can. While nuclear energy is a possible solution to our issue of climate change, others disagree. There are three basic reasons to say no to nuclear: it can be extremely dangerous, it can produce radioactive waste, and it spreads nuclear weapons. Chernobyl and Fukushima were the two largest nuclear disasters in human history, and both were caused by poor regulations and failure to follow the rules. There are numerous sources documenting the disasters of Chernobyl and Fukushima, so I'm not going to go in depth. What you need to know is that in Chernobyl, the operators failed to properly follow protocol in a routine test and caused the explosion which damaged the reactor. In Fukushima, the nuclear reactor was built to maximize economic gain rather than safety. In fact, there are numerous reports of the company in ownership of the reactor at Fukushima, TEPCO, failing to meet standards. Human error did play a part in the disasters, but it was the reactor design that was inherently dangerous. Both Fukushima and Chernobyl were light water reactors. This means uranium is enriched and formed into pellets. Enriched uranium is the equivalent to premium gasoline. This enriched process creates a byproduct of depleted uranium. Depleted uranium is the equivalent to regular gasoline. More on that later. Those enriched uranium pellets are placed into baths of water. The water acts as a coolant and helps contain radiation. In order to control the power output, control rods are used to slow down the reactions and reduce or increase heat output. By mismanaging the control rods, the reactor can go out of control and explode. Light water reactors are the most common types of reactors found throughout the world. However, in these reactors, danger is inherently built into the design, but there are other models of reactors with varying properties. For example, liquid metal reactors use liquid metal as a coolant rather than water. The metal acts as a more efficient coolant and makes for a safer reactor. This is just one of the many other types of reactors that outclass the old-fashioned light water reactor. The second issue is that of nuclear waste. We've all heard of nuclear waste. It's that bright yellow substance that nobody wants to touch. The main issue isn't that it can easily cause radiation poisoning. It's that nuclear waste exists for a really long time. Uranium waste, in particular, lasts for tens of thousands of years. The fuel rods alone have to be soaked in water for up to 10 years after use. The longevity and danger of managing this waste is a major deterrent for nuclear facilities. One solution to this problem are thorium reactors. Thorium reactors can theoretically produce less radioactive waste. The thorium waste will only be reactive for hundreds of years, in contrast to the uranium, which stays reactive for tens of thousands of years. As a result, thorium waste is much more manageable in the long term. Alternatively, we could use reactors from nuclear startups such as TerraPower. TerraPower has designed a reactor that can use depleted uranium as fuel. Depleted uranium previously had no other use after being a byproduct of enriched uranium. A large amount of waste is actually depleted uranium which has never been used. This means we can reuse our nuclear waste and make a more efficient uranium life cycle. The third issue is the spread of nuclear weapons. Anybody could identify the telltale mushroom cloud of a nuclear bomb. This is easily the most prominent issue of nuclear reactors. The first nuke was built in 1945. Named the Trinity, it exploded with a force of 22 kilotons of TNT. Ever since, many more countries have developed nuclear weapons. Many countries have developed them under the guise of nuclear reactors. It is incredibly hard to distinguish between nuclear weapon manufacturing and reactors. And so, with the spread of nuclear technology, there is likely to be more nuclear weaponry. Even at our current level, nuclear weapons are powerful enough to destroy most life on the planet with ease. As these weapons are extremely difficult to regulate, the risks of misuse are extremely high. I am not going to sit in my computer and tell you nuclear energy is great. I am not going to tell you that it's a perfect solution. I am not going to tell you it is the key to our future. It is not a permanent solution and it is far from perfect. But you need to choose between the bad and the worst. Let me ask you one question about nuclear energy. Is it better or worse than fossil fuels? I don't have an answer to that question. But that's where you come in. I want to know what you think. Do you have an idea that could change my point of view? Can you think of a solution? Let me know in the comments below because I want to know what you think. Because tomorrow, you are the ones with the power to change something. Tomorrow is a different day with a different story. I want tomorrow to have clean energy. I want tomorrow to be sustainable. I want tomorrow not to have to deal with climate change. This is my tomorrow. What is yours?